here, we're assessing the fit of a line. After we find the least squares line, we should examine how well the model fits the data. So, important questions to consider. Is a linear model really appropriate, or would a curved model be better? If we make predictions with the model, how accurate will our predictions be? And if there are any unusual aspects of the data we need to consider, are there any unusual aspects we need to consider before we make predictions? So what we're really going to address today is question 1. Well, we'll probably address all of these. Question 1, first of all, is a linear model appropriate, or should we use a line for the data? And the correct answer to that is we can only decide that if we use a residual plot. So a residual plot gives us a closer look at the pattern of the residuals. So it plots the x values on the x-axis, and the residuals on the y-axis. And the residuals are y minus y hat. That's how you calculate residuals. So on the y-axis you put the residuals. And the reason we have 0 in the middle is because residuals are positive and negative. They're above the line or below the line. So we make a residual plot. And I'm going to show you exactly how to make a residual plot on your calculator. It's really easy. Really easy. So we make a residual plot. So the residual plot should look, you know, it's going to have some points above and below the line. But this is saying, well, one of the points was this far above the line. And this is saying this point was that far, you know, -2, it was 2 below the line. And this was 2 above the line. So now these lines aren't part of a residual plot. I'm just using that. So we plot the x values, the normal x values from our list against the residuals. Okay, so the residuals, in general, I want you to think of residuals as the distance. A point is from the least squares regression line. The distance a point is from the least squares regression line, y minus y hat. That's in words what the residual means. So this residual plot right up here shows what I say no pattern. Residual plot shows no pattern. Okay, that's what we want. So what you need to write down here is a linear model is appropriate if the residual plot shows no pattern. A linear model is appropriate if the residual plot shows no pattern. This is the only way that you can be sure that you should use a line, a least squares regression line, to predict values. Okay, so what does it mean? How do you tell if a linear model is not appropriate? Well, if I graph the residuals over here and the x values on the x, and I get a residual plot that looks like this, would you say there's a pattern there? This has a pattern. So, what would I do in this case? In this case, a linear model is good, appropriate. A linear model is good because there's no pattern in the residuals. In this one, linear model, not good. Linear model not good because this has a pattern. Linear model would not be appropriate because there is a pattern here. You can see a definite curved pattern. So I've entered my data in list 3 and 4. You can enter your data in list 1 and 2. I'm going to make a scatter plot. So second stat plot, make a scatter plot, and I put mine in, let's see what, list 3 and list 4, I think. Yeah. And then I'm going to hit graph, and then I zoom 9, and I'm going to draw a rough sketch of this. Now typically you would label the X and the Y with the words that they are, but we're just going to label Y and X here. So then I make my scatter plot. I'm just going to draw a rough sketch of this. So now what I want to do is I want to calculate the least squares line. So there's step 1. I sketch the original data. Now I need to find the least squares line. So I'm going to go stat calc 8. Stat calc 8. Tell it what list you have your data in. And then I hit calculate. It tells me my regression equation is y equals negative 0.71 plus 2.39x. So I got that because A is negative 0.71 and B is 0.239. Now R, just to note, is 0.98 here. It means, you know, if I sketch this line on here, they should be pretty close. So how do I get this line to show up on this graph on my calculator? Okay, sketch the residual plot. Well, sketch the original data with the least squares line. We're still trying to do that. So now we're trying to put this line on here. So now step 3, I'm going to hit the y equals button on my calculator and type that equation in to the first line. If there's an equation there, clear it and just type in negative 0.71 plus 2.39x. And then if I hit graph, y equals, type in equation, and hit graph. It should graph your linear regression line, least squares regression line, right on that graph. Does it look like a pretty good line of best fit? Okay, so now we're going to graph the residuals. So sketch the residual plot, step 4. Residual plot. This is really easy. Your calculator is amazing, and it found the residual plot. It found the residuals for you just when you calculated the least squares. When you did stat calc 8, it found all the residuals already for you. So for a residual plot, we need to go to stat plot. So second stat plot, I'm just going to go to plot 1, and I'm still going to do type 1. It's still a scatter plot. A residual plot is still a scatter plot. And I'm going to tell it wherever your X list is, and then the Y list is going to be what's called resid. You need to put the residual list in there, and all your calculators have a residual list. Where you find the residual list is you hit second stat, which gives you list, second list, second list, there it is. See up what number is, see the resid? See where it says resid? If you do second list, even if you're not keeping up with me, do second list on your calculator. And if you see, where's your residual? Are all of you on 7? Okay. So then you hit second list 7, which is residual. And now you hit graph zoom 9. So to get the residual plot, I hit stat plot, type 1, X list is wherever your X's are. The Y list is the residual. To get that, you hit second stat 7. And then you graph it, zoom 9 it, and my residual plot I did it in the wrong thing, that's why it looks so weird. There we go. All right, that looks a whole lot better. There's my residual plot. So my residual plot actually looks like this for this problem. You always sketch the residual plot on your paper. You always sketch all the plots on your paper as you're working them out. So would you say, is a linear model appropriate here? Yes or no? Is there no pattern? Do you think there's a pattern? Does that look like a line or a parabola or something? No. So there is no pattern. So a linear model is appropriate. There is no pattern, so a linear model is appropriate.